Outside of peak season, a ticket from New York to London might cost around $500. A few days later, as more people search for the same flight, the price jumps to $1,000. This is dynamic pricing, a data-driven process that adjusts prices in real time based on supply, demand, competitor pricing, inventory level, and individual consumer behavior. For decades, the price tag was a static agreement between a buyer and a seller. But in the modern economy, that agreement has been replaced by a real-time price tag. Behind the infrastructure of your favorite apps, a silent architecture of algorithms is working in the millisecond range. The objective of this is to maximize corporate profit by matching a consumer's exact willingness to pay. Whether it's the surge pricing on your late-night Uber, the fluctuating rates of a hotel in a busy city, or the shifting cost of electronics on e-commerce platforms, studies have found that these AI pricing systems are much more powerful than the traditional one. In fact, they can increase the company's total revenue by up to 22%. To understand how AI decides your price, we first have to look at what the algorithm sees. Take Uber for example. When you open the app, you aren't just an anonymous user. You are a highly specific collection of data points known as a digital fingerprint. First, the system ingests contextual data. The algorithm knows your GPS location. It evaluates whether you are in a high-income zip code. It also looks into the weather to see if it is raining. In the event of a sudden downpour, people are more inclined to accept higher ride-sharing fares. Next, there is hardware profiling. There has long been an industry secret regarding hardware proxies. If you are searching for a hotel on the latest MacBook Pro or a brand new iPhone, some algorithms may interpret that hardware as a proxy for higher disposable income, subtly adjusting the baseline price you are shown. And other aggressive tools are urgency signals. Airline algorithms check how many people are fighting for the same seat at the same time. When the system sees a sudden spike in interest, it assumes the flight will sell out and automatically hide the cheapest tickets, forcing everyone towards the higher-priced options. Behind the scene, the system also uses session tracking. By using digital cookies, the site remembers that you have come back to look at the same flight multiple times. This tells the algorithm that you are a high-intent buyer, someone who isn't just browsing, but someone who needs that flight. While airlines often deny raising the price for just one person, they use your behavior to decide when to stop showing you the best deals and start showing you the higher prices they think you are finally ready to pay. Once your digital fingerprint is mapped, the algorithm goes to work. It stops treating you like a normal shopper. Instead, it starts using a toolkit of different checks to get as much money from you as possible. Sometimes the algorithm uses a simple approach as the classic time-based model. It might raise prices just because it's a holiday weekend or the morning rush hour. It knows you are in a hurry or on a trip, so it quietly raises the price to your schedule because it knows you have fewer choices. But things can get much more intense when the environment becomes crowded. Imagine 20,000 people leaving a stadium at the same time, and everyone tries to call a ride at once. The algorithm immediately switches to a demand-based protocol, or what we know as surge pricing. This huge price jump isn't just to make more money. It is a way to control the crowd. The high price makes some people decide to wait or take the bus, while also convincing more drivers to come to that area because they can earn more. But the algorithm doesn't just read the demand. Through geo-pricing, it draws invisible border around wealth. It knows the physical purchasing power of your exact location. A digital subscription might cost $15 a month if you are sitting in a high-rise in New York. But that exact same software will be algorithmically discounted to $3 in a developing market, ensuring the company captures users who otherwise be priced out. The machine also monitors the physical world. If a company warehouse is stuck with thousands of products that aren't selling, it triggers an inventory-driven release valve. The algorithm will automatically start dropping the price, rapidly testing different discount tiers until the physical shelves begin to clear, turning that weight into immediate cash flow. But the most aggressive weapon in the arsenal is saved for last: personalized pricing. This is where the machine stops looking at the market and looks only at the customer. It is a direct hit based entirely on customers' personal history. If the system knows the customers always pay for the expensive seat, no matter what it costs, the baseline price will quietly start to go up. Pricing has become a mirror of the buyer. The final cost is determined by who you are rather than what you are actually buying. But how does a company actually build this? From a technical side, making prices change in real time is a massive challenge. A big store or an airline can't just have people manually typing new prices. Instead, they use powerful systems that can handle a constant, massive flow of data. Every time a competitor changes a price or a customer clicks a button, that data is caught instantly. This data stream is fed directly on a machine learning model, usually built on a framework of reinforcement learning. The algorithm acts like a high-speed, hyper-rational gambler. It explores the market by slightly raising a price, and then it exploits the result. If consumers keep buying at a higher price point, the model receives a positive reward signal and keeps the price high. If the conversion rate suddenly drops, the model learns it has hit the ceiling and immediately pulls the price back down to the sweet spot. But the hardest part of the system is the speed. Everything has to happen in less than 100 milliseconds. When you click a product, the back-end system must ingest your digital fingerprint, query the machine learning model, calculate the new personalized price, and send it through the API gateway to render on your screen before the web page finishes loading. If the calculation takes too long, the user experiences lag and leaps. The algorithm is locked in a permanent race against the speed of light. However, there is a darker side to this efficiency that is just now coming to light: algorithmic collusion. In the past, if two gas stations want to raise prices together, they had to talk to each other, which is illegal. Today, they don't have to say a word. Many companies in the same industry now use the same third-party AI software to set their prices. Because these AI are all trained on the same data and have the same goal, which is maximizing profit, they learn to keep prices high across the entire market simultaneously. Today, we have officially entered an era of personalized economics. In the past, the global market was a public square where everyone sees the exact same price tag. But now, the market is a private, isolated conversation between you and a distant server. As this system becomes more sophisticated, integrating with large language models and deeply analyzing personal financial habits, the free market is rapidly transforming. It is a system capable of incredible logistical efficiency, optimizing global supply chains, and clearing out dead inventory. The next time you pull out your phone, open an app, and see a price jump on your screen, remember, it's a highly calculated execution. Thank you for watching.